YouTubers, I hope you are doing great. So today we will try to solve one of the problems in Leet code. The problem is easy, but we picked an easy problem to make it fit in our video. We'll try to explain it, try to find an solution, try to find an algorithm to fix or to solve this issue. And at the end, we will try to implement this algorithm using PHP. So at the beginning, let's try to understand the question. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways you can climb to the top? So let's take more demonstration from this example. If the input is n equal 2, which is the number of steps, and the output will be 2, because there are 2 ways to climb to the top. 1 step, then 1 step, or 2 steps. Remember, we can either climb 1 or 2 steps at a time. We can't climb more than 2 steps. So example 2, if we have the input of n equals 3, output will be 3. So the explanation will be, these are the 3 ways that we can climb 3 steps or climb to the top. So 1 step, 1 step, 1 step, then 1 step, 2 steps, or 2 steps, 1 steps. Okay, so looking on this example, let's try to find a pattern. Let's try to add our trivial cases first. So if we have, for example, let's say if we have n equal to 1, so this is our trivial cases. So if n equal to 1, so return. So if we have only 1 step, so it will only be 1 way. And if we have n equal to 2, so let's make it here or something like this, 1 step. So this is the only way to climb 1 step, is climbing that step exactly 1. So if we have n equal 2, so we have 2 ways to climb. The first way will be 1 and 1. The second way will be we climb 2 steps once. So the return value will be 2 ways, like this. So let's think of the next, if n equals 3, and try to notice a pattern. So if n equals 3, so I think it will be 1, 1, 1, or it can be 1, 2, or it can be 2, 1. So I don't think there is any other ways. So these are the 3 ways that can be used if n equal to 3. So let's align this a little bit. Okay, so we will return 3 ways. So let's try n equal 4. N equal 4 will be something like, we can say 1, 1, 1, 1, or we can say 1, 1, 2, or we can say 1, 2, 1, or we can say 1, no, this is 4, yes, this is 4, 1, 1, 1, 4 ones, or 1, 1, and 2, and 1, 2, 1, or 2, 1, 1, or even 2 and 2. I think this will be the case. So as you can see, we have 5 ways in this step. If n equal 4, so we have 5 ways. These are the only 5 ways available if we need to go to the top in only 4 steps. Okay, or if the top is far away, 4 steps. So if we notice something, n equal 2, n equals 3, equal 3 ways, which is the summation of 1 and 2. So 3 here is the summation of 2 and 1, and also 5 is the summation of the previous 2 ways, 2 and 3. So we can say that n of I equal to summation of n of I minus 1 plus n of I minus 2. As we can notice this, so n of 3 is equal to 3 ways, which is equal to the sum of 1 way plus 2 ways for the previous steps. And if n is equal to 4, so we have 5 ways, which is the sum of 3 plus 2. So this is the case, and this is the pattern we have noticed. We can implement this pattern or implement this function to find this using our trivial cases. We will think of n equal 1 and n equal 2, our base cases or trivial cases that we will use to calculate n3, n4, n5, any n we can have. But we can use multiple solutions for this problem. One of them is the recursive solution. I like the recursive solution. So we will create a function that will call itself until it finds the number of ways for any n of this n. So let's try to implement this. Okay, so let's try to implement this function. See, so here is our main function which has n. So let's create a function. Let's say it's like Fibonacci series. If you know the Fibonacci series, every number of Fibonacci series is formed of summing up the previous two numbers. So it's like Fibonacci series. We wanted to implement this using recursive function. So let's say the name of the function calculate n, for example, and it will take somehow a number n, the same n, and it will return, it will have fn equal to 0, it will return 0, fn is equal to 1, it will return 1. So we can say, let's say if n is less than or equal to 2, return n, else return calculate n on n minus 1. So we can say, okay, so now we can say for this n, we can say we will have a case of 2 and 3. Okay, so let's try to return calculate n on this n, try to run and see the result. Okay, of course we need to call this. Call to undefined function calculate n y in solution.php. So what's wrong with this function? Yes, this one, this calculate n, yes, I think. Okay, case 1 is passed, but for case 2 it's not working, the output is 2. So we can say now if we have n equal 2, so we can say if we have some n, we need to calculate this n. So if n is more than 2, so it will be return this calculate n on n minus 1 plus this calculate n minus 2. I think this would work. Let's run again and see. Yes, it's working. Okay, that's fine. Let's try to run all the test cases and submit. Time limit exceeded, okay, in N44. So it's trying to find this, but it's taking too much time. So let's use this test case. N equal 44, okay. So what's wrong with this test case? The recursion, sometimes it takes some memory and takes some time. So if we have something like okay, let's try to replace this recursion. It's working for most of the cases, but it's taking some time. This is the problem, the only problem. So let's try to replace this recursion and try to implement another solution. So basically we know that we will take this again and say if n is more than or equal to 2, then return n. So else, so we will make a for loop for I equals to 2 and I is less than n, less than or equal to n and I plus plus. So we can say, for example, if I is equal to 3, so it will be the total number, which is, we need to define here, n1 equal to 1, n2 is equal to 2. So for I starting by, we say 3, let's start by 3, it will be, we have something like sum equal to 0, and we can say sum will equal to n1 plus n2, and then we have, okay, so if we sum up 1 and 2, so it will be 3. For n equals 3, it will be 3 ways. The next time for n equal 4, we need to change the value of n1 and n2 to be 3 and 2. So we need to change the value of n1 and n2. So for example, n2 will make it equal to n1, and for n1 we will make it equal, or n2 will make it equal to sum, and n1 will equal to n2. So first n1 will take the value of n2, so in the next time n1 will be 2 and n2 will be 3, so the sum of them will be 5, and this will be sum plus equal n1 plus n2, and at the end I think we need just to return this sum. Okay, let's try to run these test cases again. Okay, so case 3 is not working. Output is giving a very big number. And why is this? So we said sum is equal to, oh, we don't need to use plus equal, just sum equal. Okay, let's run again. Okay, it's now working. So each time it will go and change the value of n1. n1 is initially equal to 1 and n2 is initially equal to 2. So if I is equal to 3, so it will be 3. If I is equal to 4, so it will be, we need to change the n1 and n2, the two values of n1 and n2, to be the previous two steps. So it will be 3, this will be 3, and this will be 2. So the sum will be 5. After that, we need to change this again. So this 2 will be 3, and this will be 5. So the sum will be 8, and so on and so on. So let's get this back to the original values, like this. Run again. Okay, let's try our solution against the all test cases. So it's accepted. Beats 39% and memory is 19.6 megabyte. So we can think of, let's think of a better solution, but currently we have make it work. So we need to find much better solution for this. So what can we think of to optimize this solution? I think we can we give away of this for loop? Can we do something else? So the recursion didn't work for some test cases, but the for loop is working, but it's taking too much time. So what should we do to avoid this time? So the time complexity here will be big O of n, so we just have one for loop, but I don't know why it's giving me that it's not very good solution. It should be a good solution. Okay, only beats 39%. So let's look at other solutions and see. Basically it's a Fibonacci, so let's take the first one and see what's happening if n is less than or equal to 0. These are the base cases. We have already done this in one single condition, one step. Okay, it's using the same way. It's using the same way we are using, and it's not giving. Okay, that's it for now. If you reached the end of this video, so thank you for watching this video, and I will see you in the next one.